Remember the old days of the internet? The days of the dial-up modem, that glorious symphony of shrieks and static that was our gateway to the digital world? You'd click on a link to see a picture of, say, a cool new rocket launch, and then you'd wait, and wait, and wait some more. You could practically go make a sandwich, do your homework, and come back just in time to see the image slowly, painfully paint itself onto your screen, one pixelated line at a time. It was a test of patience, a digital trial by fire. That agonizingly slow crawl was just the price of admission to this amazing new frontier. We accepted it because, well, we didn't know any better. That experience feels like ancient history now, doesn't it? Today we expect things to happen instantly. We tap a link on our phones and a high-definition video starts playing immediately. We click Buy Now on a shopping site, and the next page loads before our finger has even lifted off the mouse. We've become accustomed to a web that is fluid, responsive, and incredibly fast. It's so seamless that we rarely stop to wonder how it all works. Did the entire internet just get a massive upgrade overnight? Did someone invent faster electrons? The change wasn't one single thing, but a collection of brilliant innovations working behind the scenes. The transition from that slow, clunky web to the lightning-fast experience we have today is one of the greatest and most overlooked engineering triumphs of our time. Think about it. The internet has grown exponentially more complex. We're not just loading simple text and a few grainy images anymore. We're streaming 4K movies, playing interactive online games with people across the globe, and accessing vast libraries of data in the blink of an eye. The sheer volume of information flying around is staggering. Logically, things should have gotten slower, not faster. So what gives? What's the secret ingredient that keeps everything moving at the speed of thought? The answer lies in a concept that is as simple in its brilliance as it is powerful in its execution. It's a system designed to cheat distance, to bend the physical limitations of the world to our digital will. It's the reason a video hosted on a server in California can play instantly on a phone in Tokyo. This incredible feat of engineering is made possible by something called a Content Delivery Network, or CDN. It's the hidden backbone of the modern internet, the silent workhorse that makes our daily digital lives possible. And today we're going to pull back the curtain and see exactly how this amazing technology works. So, what is this magical thing, this content delivery network? Let's break it down. At its core, a CDN is a globally distributed network of servers. That's the fancy way of saying it's a whole bunch of computers strategically placed in different locations all around the world. Their one and only job is to get website content, the images, the videos, the text, the code, to you as fast as humanly and technologically possible. Think of it like a massive, super efficient postal service for the internet. Instead of every letter going back to a single central post office, this service has thousands of local branches ready to deliver the mail. Imagine a website is like a famous pizza place. Let's say the original, one and only location is in New York City. If you live in Los Angeles and you want one of their pizzas, they'd have to bake it in New York and then ship it all the way across the country. By the time it gets to you, it's going to be cold, soggy, and disappointing. A CDN is the pizza place's brilliant solution. They open up franchise locations in every major city, including Los Angeles. Now, when you order that pizza in LA, you're not getting it from New York, you're getting it from a local kitchen that has the exact same ingredients and the exact same recipe. A CDN does precisely this for websites. It takes the original website's files, the images, videos, and scripts, and makes copies of them. It then stores these copies on its network of servers located all over the globe. So when you visit the website, you're not connecting to the original server in New York, you're connecting to the closest server right in your region. This is the fundamental principle of a CDN: reduce the physical distance that data has to travel. Let's dive a little deeper into the mechanics of this operation. The process that makes a CDN work is called caching. It's a word you might have heard before, maybe when a tech support person told you to clear your cache. In this context, caching is the act of storing a copy of something in a temporary, easy-to-reach location. Your web browser does this on a small scale, saving bits of websites you visit often on your own computer so they load faster the next time. A CDN takes this idea and applies it on a global scale, using its network of servers, which we call edge servers. These edge servers are the key. The edge refers to the edge of the network, as close to the end user, that's you, as possible. When you, sitting in your home in Chicago, try to access a website that uses a CDN, a beautiful process kicks off. The CDN doesn't send your request all the way to the website's original server. which might be in Germany. Instead, it intelligently redirects your request to the nearest edge server, maybe one just a few miles away in a Chicago data center. Think of it like a librarian. The main library, or the origin server, has every book ever published. But going there is a long trip. So the librarian sets up small, local branch libraries, which are the edge servers in every neighborhood. The first time someone in a neighborhood asks for a popular book like Moby Dick, the local librarian orders it from the main library, but then, they cleverly keep that copy on their shelf. The next 100 people in that neighborhood who want to read Moby Dick can get it instantly from their local branch, without waiting for it to be shipped from the main library again. That's caching on an edge server, and it's what makes the web feel instantaneous. The most obvious benefit of a CDN is, of course, speed. We've talked about how reducing the distance data travels slashes loading times, a phenomenon known as reducing latency. For users, this is a game changer. A faster website means a better experience. Videos don't buffer, images appear instantly, and pages don't leave you staring at a blank white screen. This isn't just a matter of convenience, it has a real psychological and economic impact. Another huge advantage is reliability and availability. What happens if a website's main server, its origin server, goes down? Maybe there's a power outage at the data center, a hardware failure, or it just gets overwhelmed with too much traffic. Without a CDN, the website would simply be offline. But with a CDN in place, the story is completely different. The network's distributed nature provides an incredible safety net, a kind of digital shock absorber for the entire system. Furthermore, CDNs are masters of what's called load balancing. If one edge server in their network gets too busy or has a problem, the CDN's traffic management system automatically reroutes visitors to the next closest healthy server. This distributed architecture also leads to a third major benefit: reduced bandwidth costs for the website owner. By using a CDN, the vast majority of requests are handled by the CDN's edge servers, not the origin server, dramatically lowering its bandwidth usage and hosting costs. The world of content delivery networks is a fascinating ecosystem, and at the top are a few major players who handle a mind-boggling portion of the world's internet traffic. One of the most well-known names is Akamai. Founded in the late 1990s, Akamai is one of the original pioneers of the CDN industry, born out of a challenge at MIT to solve internet congestion. Another powerhouse is Cloudflare. While newer to the scene, Cloudflare has made a colossal impact by making CDN technology accessible to everyone, from individual bloggers to massive enterprises, offering powerful security features and easy setup. And of course, no discussion would be complete without mentioning Amazon Web Services and its CDN offering, Amazon CloudFront, deeply integrated with the entire suite of AWS products. Let's start with your Friday movie night. When you fire up Netflix, Disney Plus, or any streaming service and press play, you are witnessing a CDN work its magic in real time. Streaming services don't send that movie from a single server farm in Hollywood. Instead, they use CDNs to place copies on edge servers worldwide. When you start streaming The Mandalorian in London, you're pulling it from an edge server likely located right there in the UK. This is why you can jump to any part of the movie instantly, and why the picture quality can be so high without constant buffering. Now let's think about online shopping. When a big e-commerce site launches a major holiday sale, it gets hit with a massive surge of traffic. A CDN acts as a traffic cop and shock absorber, distributing the load across its global network. Perhaps one of the most critical roles for CDNs today is in cybersecurity. A distributed denial of service attack floods a website with overwhelming junk traffic. A CDN is a website's best frontline defense, absorbing the attack and filtering out malicious traffic at the edge. In our exploration, we've peeled back the layers on one of the most important, yet least visible technologies that power our daily lives. Content delivery networks are a testament to human ingenuity. They are the reason a small business owner in Ohio can sell her handmade crafts to a customer in Australia just as easily as a mega corporation. CDNs democratize speed and reliability, leveling the playing field and allowing websites of all sizes to provide a world-class experience. You don't need to be an internet giant to benefit. Many CDN services are incredibly affordable, or even free. Think about all the things we take for granted on the web today. Instant access to information, seamless video calls with loved ones across oceans, the ability to collaborate on projects in real time, and the joy of immersive online entertainment. None of it would be possible at the scale and speed we experience without the silent, tireless work of CDNs. They are the ultimate behind-the-scenes crew. They don't have a flashy user interface or a logo on your screen. Their success is measured by their invisibility. When the internet just works, when it's fast, stable, and always on, that's the sign of a CDN doing its job perfectly. It's a beautiful system, really. It takes a problem rooted in the physical world, the time it takes for light to travel through a fiber optic cable across a continent, and solves it with a clever distributed architecture. It's a solution that is both elegant in its simplicity and staggering in its global complexity. The engineers, the architects, and the operators of these vast global networks are the true unsung heroes of the digital age. They are the road crews, the air traffic controllers, and the postal workers of the internet, all rolled into one. They built the invisible engine that drives the modern web, ensuring that our shared digital world remains fast, resilient, and open to everyone. The web is so fast not because of some single mythic breakthrough, but because of the steady, brilliant, and distributed work of CDNs, and that is no myth.